Hey guys, so this is the most requested video I've ever had. So many people have asked me to solve this one in the last 3 days. To make this easier to look at, I'm going to get rid of the 4s and these outer circle pieces. We don't really need those right now. Here's what it looks like. I'm only going to look at the top piece because once we find that, we can just multiply by 2 to get our whole answer. Let's duplicate this twice and get rid of the shaded region. Let's make an equilateral triangle. We're going to do the radius from here to here, and we're also going to do the radius from there to there. And that's the radius of one of those outer 2 circles that we already got rid of. Then if we duplicate that triangle and have 4 of them, we now have 4 equilateral triangles inside of our circles. For this circle, I want to look at the sector right here. A sector is like a slice of pizza. It's got the curved edge for the crust, and then it's got the point. And then for the second circle, I want to look at these pieces right here in orange. So the thing we're looking for is going to be equal to this sector minus these orange things. And you can see how that works here. We have the green thing minus these orange things. So the green that's left over is the same thing as our blue piece right here. So now that we figured out how to do this partial piece, we can double it to get the whole thing. We're going to end up doubling whatever we get when we calculate this. The formula for sector is pretty easy, so this green one is not hard, but this orange one's a little trickier. Let's look deeper into the orange one. Let's split this thing up into 2 circles as well. For this first circle, let's zoom in a little bit. Let's draw our triangles. And then let's get rid of our inner circle. So these are both equilateral triangles with the radius of this circle as the side. Now let's get rid of these 2 pieces here. And now we have 2 sectors again. We'll color them purple. So if we bring our inside circle back, you can see how those 2 sectors fit just inside of this interior circle. This is what I want this circle to be right here. It's those 2 sectors. And then for this last circle, we're just going to take these 2 equilateral triangles. Now we're going to subtract this circle minus this circle. After we subtract the red triangles from the purple sectors, we're left with these little purple slices here. That is the same thing as these orange slices. So we can set them equal to each other. Now to make things neater, I want to switch both these equations, and then I want to smush them together. So let's copy everything down. And this circle with the orange pieces, I want to substitute the purple minus the red. And that's going to look like this. Next, we can bring this down and distribute the negative to the purple. So negative purple is just negative purple. And then negative red is going to be positive red. Now we can start using some equations. We have a 2 on the outside. The area of an entire circle is pi r squared. And this sector is 60 degrees out of the whole 360. So we'd say 60 over 360. And then we subtract. And each of these purple sectors is the same as this green one. So we have 2 of these 60 over 360 pi r squareds. And then we can add this red stuff to that. The area of an equilateral triangle is root 3 over 4s squared. And if you want me to prove that, I can do that in another video. The side of this here is equal to the radius, so I'm going to change that s into an r. And then since there are 2 triangles, we can double it. So this 60 over 360 can be reduced into 1/6 pi r squared. And this 60 over 360 can also be 1/6. And then we can bring this down and we can bring down the 2. Now let's distribute the 2. 2 times this is just 2 times that. 2 times this would then be minus 4 times that. And then 2 times this would be plus 4 times that. Let's bring the red part down, and then 2 of something minus 4 of something is negative 2 of that something. And then negative 2 times 1/6 is negative 1/3. And this 4 and this 4 are going to cancel each other out, leaving us with root 3 r squared. The original problem had 4 for the radius, so we can plug 4 into the radius for both of these. And on the left hand side, 4 squared is 16, so that gives us negative 16/3 pi. And 4 squared here is also 16, so we end up with 16 root 3. This is the answer to the question. The area of this problem is negative 16/3 pi plus 16 root 3. How exciting.